All right, let's continue looking at slope fields and their properties. We want to be able to draw a slope field, and possibly we want to be able to identify the appropriate slope field through some matching activities. Okay, so let's start with dy dx equals negative x over y. And we're going to just kind of study this for um, a variety of points as we're kind of looking around in different quadrants. So if we start with the point 1, 1, then dy dx, which is negative x over y, is going to be negative 1. All right, and then if we go to negative 1 over 1, then we get positive 1. And then negative 1 and negative 1, that's going to give us negative 1. Just plugging into our formula for dy dx equals negative x over y. And then we get positive 1 here. All right, so this point is in quadrant 1. This point is in quadrant 2. This is quadrant 3 and quadrant 4. Okay, so we can say dy dx is going to be positive in quadrants 2 and 4. And it's negative in quadrants 1 and 3. Okay, all right, so that's some information that we can use. In just a second, we're going to be drawing these, but we'll come back to that point or part in a minute. Okay, part B, we're looking still at some points. Remember, dy dx is equal to negative x over y. All right, well, for these points, they all have a y coordinate of 0. So dy dx is going to be undefined for each of these points. All right, if you'll permit me, I'll just kind of extend undefined through for all of all of the points that we're looking at here. Okay, so what are we talking about here? What do we know about a line where the derivative or the slope would be undefined? Okay, we're talking about a line that is a vertical line, right? Vertical lines mean that the x values, uh, if we're talking about undefined slope, yes, the x values are all the same. So it takes the form of x equals a, right? And if the slope is 0, we're talking about y equals b. So what that means is at these points, we might draw little vertical line segments for the slope field. Okay. All right, so we'll come back and look at those in just a moment. All right, we've got here some more points. At 1, 1, we're going to get negative 1. At 2, 2, we get negative 1. At negative 1, negative 1, we get negative 1. And negative 2, negative 2, we get negative 1. Okay, so what equation would express dy dx is equal to negative 1? And that would be y equals negative x. Or dy dx equals 1, this would be y equals positive x. All right. Okay, so now we're going to start sketching in some of the information that we have. So if we go back to part A, okay, and it depends on how you want to do this. I'll sketch in the positive ones first. It helps me, especially using the tool that I have here now, to kind of put everything that's supposed to have the same value of slope, kind of sketch those at the same time so that I can keep them together. But if I go to minus 1, 1, I want to have a positive slope of about 1. Okay. Um, and then we got 1, -1. So same slope there. Okay. All right, then I can start doing some of my negative ones. So if I go to 1, 1, we got a slope of -1. So same steepness, but we're just going in a different direction. Okay, we want a negative slope. All right, so both of those are supposed to be 1. All right, at 1, 0, I could have kind of a vertical slope or a vertical line segment. Okay, all right, that's where our slope would be undefined. All right, then we can go on to 1, 1. Did we do? We already did that one. Let's see, where are we? At 2, 2, we've got -1. And at -1, -1, -2, -2, we've got -1. Okay, what's going on at -1, 2? Did we look at that? I don't think we looked at that point yet, because I think I've got everything so far. All right. And we could continue on with this, sketching in a few more points. I'm curious, if we haven't already done it, what's going on at -2, +2? Okay, we didn't do that one yet. So if we do -2, +2, then that's going to give us a +1. All right. And if we do +2, -2, we still get +1. All right. And so I think we're starting to see the picture here. Okay, we know we got vertical lines here. What we didn't do was any places where it would be equal to 0, right? So if our derivative dy dx is equal to -x over y, then that means whenever x is equal to 0, the derivative is 0. So that's going to be right here on the y-axis. So I would have little slants, little line segments like this on the y-axis. Okay, and so I think it kind of becomes apparent that we have this circle pattern going on for our slope field. Okay. All right, so it says use in part D, we use the grid at the right to sketch the slope field for the values calculated for A, B, and C. We added a few extra values. Then it says draw the particular solution that passes through the point 0, 2. Okay, so here is 0, 2. All right, and so we've got this circle pattern going. I'm going to be out here at 0, -2, and 2, 0, and so forth. So I'm sure my circle is not going to be that great. Okay, but there's our solution. Okay, that's a particular solution that we found. Okay, for F, it says, what is the equation for this solution curve? Well, we already know that the formula for, or the equation for a circle looks like x squared plus y squared equals r squared. So we get x squared plus y squared. Our r in this case is 2, so it's going to be equal to 2 squared, or 4. All right, so what can we learn from the slope field? It says explain what happens to the slope values as you move from left to right with a fixed y value. So let's go back and look at our slope field. All right, we may need to fill in a few more values, but I'll have you look at the slope field that is in our in the course notes, the notes key, and we can kind of see what's going on there. Okay, so here's the completed picture of the slope field in this, or for this equation. And now we can answer parts G. It says explain what happens to the slope field values as you move from left to right with a fixed y value. Okay, so let's take this line. All right. Lock this down. So if we look across this line to see what's happening with the little slope lines, we can see that we started out being positive. Not sure what happened here because it's a little crazy. I don't think it increased. But we had this. If we look at this line, it looks like we got a positive slope. Maybe this decreases a little bit. This is definitely a decrease. This is 0. Now this is negative, so that's another decrease, and it's even more negative and more negative. So as we go across for a fixed y value, at least above the x-axis, we can see that the value of dy dx is decreasing. Okay, so I would say if y is greater than 0, then dy dx decreases. When we look on the bottom, we can see that it starts out negative, all right, and then it's less negative and less negative, and then 0. So we're actually increasing, right? We go from 0 to positive and more positive and positive. So for y's that are less than 0, dy dx increases for a fixed value of y. Okay, when again y is less than 0. Okay, so let's look at H, where they want us to evaluate what happens as we move up from the x-axis. Okay, so suppose we look at dy dx equals negative x over y. That's what we're working with. And I'm going to choose the vertical line where x is equal to negative 2. Okay, so if we put in negative 2 for x and y is 1, then we get positive 2. Okay, that should be a positive 2. All right, and then if we go negative 2 to positive 2, then that's going to give us a positive 1. And if x is negative 2 and y is 3, then we're going to get 2/3, right? So we can see that dy dx for this fixed value of x is going to be decreasing as we move up from the x-axis. If we go to the other side, let's say we're looking at this area. We've got x equals to 2, okay? So if we do 2, 1, that's going to give us a slope of negative 2. And if we go to 2, 2, that's going to give us negative 1, which is an increase. And if we go to 2, 3, we get negative 2/3, which is yet another increase. We're going towards 0. We're going up. So that's an increase. So we can say for x values that are less than 0, dy dx decreases for a fixed value of x. And for x values that are greater than 0, dy dx increases for a fixed value of x.